I'm Joe DalSanto, Professor of Astronomy here at the College of DuPage. I have been here for about 10 years, and I've also had the privilege of serving as the Earth Science Department Chair, in which I can assist other professors with their courses in Earth Science. And I, in particular, of course, also teaching the astronomy courses. So the James Webb Telescope is our latest and largest space telescope ever put out into space. Astronomers are very excited about it. It's taken a long time to build it and test it and launch it. James Webb is special because, again, it's so much bigger than, for example, the Hubble Space Telescope. The mirror on James Webb is about 6.5 meters across. Hubble's about 2.5 meters across. So you can see that's much larger. And James Webb is also very unique with its technology, very sophisticated. It had to be built in a manner that it literally is folded up for launch and then sent out into space, at which case it unfolds. It also had to be sent quite far from Earth. It's not orbiting the Earth, it's orbiting a point in space farther from the sun than Earth, but basically in a line, what we call the L2 point, where the gravity of the Earth and the sun balance. And this way it stays in a particular location. The reason for that is James Webb needs to be very, very cold. It is optimized to view infrared light, which is longer wavelength than the visible light you and I see with our eyes. And the reason it's optimized for infrared is because astronomers want to study the universe at that wavelength. In particular, one of its major goals is to see the farthest possible objects we can see out into space. That essentially means we're looking back in time because the light takes time to get here. And so by the time it has traveled a long distance from the greatest possible distances, space itself has stretched out the light waves. And so they are no longer visible light waves that we could normally see with a normal telescope, but they are now infrared light waves. So the ability to see the infrared light means it will be able to see farther than any telescope before. And astronomers, of course, are very excited about that. It'll also be used for other objects closer to Earth, but in particular, that's one of its major goals. So very exciting new telescope out in space for us. Well, it was obviously designed to be much better, and it's very early, but we do have already a few early images. Let me share a comparison of two earlier infrared telescopes. You can see the WISE telescope some years ago gave us a first good look. Then the Spitzer Space Telescope, its successor, gave us a better look. But clearly you can see the dramatic improvement here on one of the very first images coming back from James Webb Space Telescope. Not only far sharper and crisper, but we see many more stars in the view. So I think this one image already shows us how much better James Webb is than its predecessors. Well, just that we look forward to some amazing discoveries. And that's really the point, is to find things we've never seen before. I always enjoy hearing the latest discoveries. And I also enjoy sharing that with the public. Our entire COD community, our entire district, I have each term presented for the public. And many of those have been recorded and put out on YouTube. So if you simply search on my name, Joe DalSanto, and College of DuPage, you can find quite a variety of recordings on various topics that I've done. Hubble Space Telescope, infrared astronomy, the history of astronomy, many other topics that I think you'll enjoy. So I hope you'll take advantage and view a few of my videos out on YouTube.
Have you always been curious about the science around you? Submit your question and it could be featured in one of our upcoming videos. Visit cod.edu/STEM and click on So That Explains It.